This is the solution of the previous activity where you have to power on the LED when the button is pressed and power off the LED when the button is released or simply just not pressed. So first of all, we are going to write the basic code that we need to simply be able to use GPIO. Okay, so the configuration stuff first. So import rpi.gpio as GPIO. Then we also will need to import time because we are going to use time. Then GPIO.setMode with GPIO.bcm. Okay, so we can use the GPIO number. Then we are going to set up our LED and set up our button. So GPIO.setup, we need to provide the LED pin. So I'm going to do that LED pin 17. Okay, that doesn't change. Button pin 26, that doesn't change either. And then GPIO setup LED pin with GPIO.out and GPIO setup with button pin GPIO.in. Okay, make sure you don't mix those. So now everything is set up. I'm going to write GPIO.cleanup for the end of the program before it exits. And now, okay, what we want to do, we want to keep monitoring the button state. So every time the button states change, we can simply modify the LED. So we can power on the LED or we can power off the LED. So what I'm going to do, simply while true. So I'm going to make an infinite loop so we can always check on the button. And I'm going to do if GPIO.input button pin. Okay. So what we do is we check. First we read, okay, what is the value from the button. If this is equal to GPIO.high, okay, so the two equal sign, we test that condition. We read the button state. If the button state is high, and what we do is we power on the LED. So GPIO.output LED pin with GPIO.high. And I can put else, okay? I could put if GPIO input is equal to low, but anyway, it is a binary state. So if it's not high, it will be low. So I can just put else and GPIO.output LED pin GPIO.low. Okay, and actually let's try that. So run the script. I can save it as activity 5. And let's see what happens. Okay, so that works. We continuously check the button state, and then depending on what is the button state, we set the LED to high or low. And finally, the cleanup is here, but as you already know, because we keep going in this while loop, then when I stop the program, this will not be executed. So when I run the script again, we will have that warning, okay, but this is something you can skip for now, and that we're going to solve later in this course. And actually this program is running great, but we will need to add something else, okay? We will add a time slip with a very low amount here between each iteration of the while loop. Because right now, what is happening is, you give a while true, and inside you just execute some code, okay, that doesn't slip, that doesn't wait for anything. So it will execute the code at the max speed from the CPU, okay? So to make you understand that, I'm just going to go here, okay, and go to accessories and task manager. And let's put that here. Okay, as you can see, the CPU usage is something above 25, so 27% here. You have to know that on the Raspberry Pi, you have 4 different cores. So you have 4 CPUs. So if you have a CPU usage of 25% here with one program, it means that one CPU is full with just one program. Okay, if I stop here, I go back to Task Manager, you can see that the CPU usage with nothing running should be about 2% here. Okay, I just have the Tony IDE and some other stuff, but the CPU usage is really low. And if I run the script, the CPU goes up to 27%. Okay, so it means that we added 25% of CPU usage, and because we have 4 CPUs, it means that one CPU is completely full with that program, okay, which is not that great. So what we can do here, in the while true, we can simply add time sleep, for example, with 0.01. And you are going to add that not inside the if or inside the else, okay? Make sure you add it inside the while true at the same scope as here, okay? So it gets executed every time you enter the while true. So you can put it here if you want, or you can also put it at the beginning. It's basically the same because this block of code will keep being executed again and again and again. So what this will change is simply that now every time we are going to wait 0.01 second, which means that this block of code will be executed at about 100 Hertz, which means 100 times per second. And running that at 100 times per second is really enough. Okay, you don't need to run it faster for this application. So now if I run the script again, so it is running, I go to the Task Manager, and you can see the CPU usage is now about, so let's wait, okay, it's 5%. And it goes even back to 2%. So we are using now, you can see 3% now. We are using a very small amount of CPU, okay? If you just put a time sleep with a low amount like this, it will make, when the program sleeps, okay, it consumes really little or none of the CPU resources, and it's much better to actually use lower CPU usage. So keep in mind that when you are actually running an infinite loop, okay, an infinite loop on purpose, in that case, when you are, for example, reading something and taking an action depending on what you have read, it's better to add a very small time sleep. Okay, you can put 0.01, or you can go lower, or you can go higher, but just put some sleep, okay, to make the program wait, so it will use much less CPU.